Hey everyone, John here, staff software engineer, 10 plus years of experience. Let's work on some data structures and algorithms. I'm the lead maintainer of the open source educational platform Latterly.io. You can go sign up for free now. It'll help you learn to code, land your first or next programming role, and grow your social and professional networks. Big focus for Latterly is going to be the interview prep, which a lot of other coding courses will miss. A big part of interview prep for programmers is data structures and algorithms. That's why I made the Latterly Neetcode Kata. It's only 12 problems, and it covers the majority of problem types you're expected to see. Now, I'm going beyond this minimal 12 problem set and going up to 3 and 500, which will be more comprehensive than the Blind 75, the Neetcode 150, and other large problem sets. And I want to make a superset of Neetcode. So I like a lot of Neetcode. Some of these I'll skip, 1DP, 2DP, bit manipulation. I don't think it's a good use of your time. I do like all of the array and hashing questions. So let's work on those. Top frequent K elements. This one is going to be hard for me. Even though it's medium, it's going to be hard for me because I'm not familiar with this kind of problem. I'm going to try, we'll see how far we get. I'm going to try and do all 4 of these ones that I haven't done yet. I suspect that the latter 3 will be easier than the former one. I could be totally wrong. Maybe I'm going to bomb all of them. But here, I think it's important to be vulnerable and show how, even as a staff software engineer, I'm rusty, it's a problem I haven't done, it's a pattern that I'm not familiar with, and so how do I address that? The way I address it is I shorten my time box. So the solution is not to skip the hard problem, right? Do the hard problems. You need to do hard problems. I dare you to do 100 Neetcode problems and make half of them easy and half of them not easy. You do medium or hard, I don't care. I dare you to do 100 of those problems and tell me that you're not passing your interviews more. I dare you. And so if you are phobic on a problem, like you just don't feel like doing it, instead of skipping it, do it and shorten your time box. Look up the solution more quickly, okay? So you'll get a few of those quick repetitions in. I'll probably need to do this problem 3, 4, 5 times for the pattern to sink in. So I'm going to do a short time box, probably look up the solution, and that's how we learn. We're not expecting you to get these on the first try. You're going to learn the pattern over time through repetition. Okay. Or maybe I'm going to get it the first time, who knows. But when I read the title, I was like, sheesh, these top case selection problems, I'm usually not good at them. All right. So we want an integer array nums. In an integer k, return the k most frequent elements. You return the answer in any order. I'm already thinking of edge cases. In an interview context, I would walk through the edge cases with the interviewer. Here I don't have that, so I just have examples. Some of the edge cases I'm thinking, what if k is larger than the length of nums? Can I just return nums? It feels like what I should do. Yeah, it says answer in any order. So that's what I'm going to do. We'll see if it passes the test case. So in the case that k is less than nums, I need to collect their frequency. Okay, this actually doesn't seem too bad. There are much more complicated forms of this that can get really hard when you want k selection on some strange sort where it's like an object, not just an integer. I think because it's an integer, this will be simpler. Follow up, your algorithm's time complexity must be better than O in log n. Is it always sorted? So here it's 1, 2, 3, and here it's 1. It's guaranteed that the answer is unique. Okay. K is in the range 1 to the number of unique elements. So K will never be larger just by constraint. It's a 1-line guard anyway. I don't think that's a big deal, but fine. I'll go ahead and express the greater than or equal to expression to handle the edge case they say won't exist, but there is still this edge case when K is equal to the number of unique elements, right? I don't see a sort guarantee. I don't. So it looks coincidental that example 1 and 2 have nums sorted. I don't see a sort guarantee, and yet we want to not sort basically because n log n will be our sorting time complexity. So if I call nums.sort in Python, that'll be an n log n operation to sort the array, right? So we want to beat that. Now it says follow up, so I could do a brute force where I sort it, and then I could do another one where I don't sort it, but I'm kind of getting a hint here that I shouldn't need to sort it, right? So I could run through and collect a set I can collect a hash map which has the value of the count for each key, and the key is an element in nums. I think that's the intuitive thing to do. But how do I get the highest? Right, so I can collect a hash set or a dictionary where the value is the element in nums and the key is the count. Then I can, in a second pass, loop through it again and collect the counts and just literally get the k. So this is going to be k. And that will be shorter because the length of k is constrained. So if k was unbounded, then you could have, it would be O of kn, right? And if k was unbounded, O of kn could actually be larger than n log n. But because it's bounded, that won't be the case. So I think that's the solution. That's the solution. So I'll get this hash, this dictionary, and get the counts and the values. And then I will loop through the values, but I can't even sort on the keys, can I? If I sort on the keys, yeah, it'll be k log k. Oh, that's funny. So we'll see. So is n times k log k faster than n log n? And if not, I'll come up with some other solution, or I'll look up the solution. So approach will be a 2-pass. Dictionary hash map where key is L of nums, value is count. In second pass, sort value counts, sort counts. So this will be k log k. Then return top 5. Or not top 5, top k. Top k. Oh no, in the worst case that will be n log n. So in the worst case they're all unique, right? In the worst case they're all unique, so that's still n log n. So I can't sort even on the keys then. It'll be asymptotically n log n. So it will be non-asymptotically less than n log n because I can just handle the edge case where they're all unique, right? And then I can return all of them if they're all unique, I suppose. Yeah, that's weird. What if there's 4 unique and then k is 3? Which do I pick? It's guaranteed that the answer is unique. So I can basically ignore that sad case. Can ignore sad case where unique L count is greater than k. So because the unique count is guaranteed to be less than k, in other words, they're equal or there's a duplicate value, then non-asymptotically, I'll never hit n log n because there will be at least like one duplicate. Chloe says, just iterate through all the entries of a map. Yeah, so if I iterate through them, how do I collect the k? Yeah, I can just maintain k best and keep replacing the loser. I think I do need to do something like that. This is like the k selection pattern that I'm not good at implementing. I think you're right. Welcome in, by the way. Thanks for being here. So I'll have some array of length k. I can just initialize an empty array of length k. And keep pushing out the losers. So what do I want to put in this array? Do I want to put tuples of the value and its count? I guess that's right. Use an array of length k with tuples of value and count. So do I need to insert the next winner? Yeah. I guess I need to keep sorting that thing or maintain its, I need to maintain the array. Push out loser at each iteration. So it's still a 2-pass. Okay, let's do it. So this will be counts map. And then here we'll have results, or like winners map. Let's call it best, like most frequent elements. And that's going to be can I just do this? I don't know if I need to put an element in there. I can say none. How about that? For num and nums. And then I'll eventually return. I won't want to return the tuples. I will just return the most frequent elements. I could reuse that same structure, but I think it's cleaner to have two. Most frequent elements. Yeah, so we'll have two of these. I'll have most frequent elements and most frequent tuples. Okay, overall time complexity is, what is it going to be? Let's see. It's definitely at least O of n. I need to pass through all of n. Because k is guaranteed to be in the range 1 to the number of unique elements. So I think it's going to be k log k, if I'm not mistaken. And then space complexity is O of n. Okay. Could use a default dictionary. That would clean this code up. I'm going to do instead the if-else pattern. So if num in counts map else counts map of num equals 1. Okay, so now we're collecting our counts, and where do I place the tuples? I won't have the tuples yet. Okay, so now I have the counts. So I'll say for pair in counts map.items, I'll say num is pair, and let's see. I think I can just split them out here. So I'll say for num count in counts map.items, most frequent tuples maybe I should do this. Most frequent tuples. If the length is at k. So we want to populate it until we reach k, right? Do I want to do less than k? Nope, I'm going to just populate it until we reach k. Else. Here I'll need to sort it. And I want to sort on the count. So in this case, I'll start with an empty list instead of multiplying by k eagerly. So most frequent tuples dot append. I think that's the JavaScript term. No, that should work, I think. So we'll add this new tuple, which is going to be the number and its count. I think if I go count first, then it will sort automatically. And I don't need to have some more advanced sort syntax if I'm not mistaken. I think when you sort on tuples, it'll try to pull the first element out of the tuple if I'm not mistaken. And I can print to verify that. That won't be super helpful because this is already sorted. All right, let's try this anyway. Let's try this anyway. So what am I expecting? Count. Yeah, 1, 2, 3. So the 3 should come first then. Most, oh, I spelled it wrong. Okay, so what did I print? Standard out was an empty list. Right, so if it's less than k, we'll add to it. Otherwise, we'll start sorting it. So here I've got 2 and 3. Where's the 3? For num and nums. Oh, because k is 2. Okay, so if k is 2, that's fine. So it is sorting on the count. Good. So if I sort, I think I can just pass -1 and flip it. No? Let's see. Yeah, there's an easy way to, I can do reverse. Sort. Okay, so now I've got 3 and 2. So the least frequent will always be at the end in that case. I guess it's fine. There's probably a more efficient way to do that, but it'll be linearly more efficient. So we want to sort and reverse. And now least most frequent is the last element. And if count is greater than least most frequent, then we want to kick that one out and add this new one in. Oh, let's see. Maybe I don't need to do that at all, huh? Yeah, I guess I can just take all of them and slice once. I can take all of them and slice once. So here, let's do this. So I'll take all of them. Oh, and instead of doing a slice operation, I will say for L in range K, And now the most frequent elements. So now we're going to go most counted, like most frequent to least frequently. So we'll go up to k, and we will append here. We'll append here. What are we going to? We'll append just the number. Just the number. So 3 is the count. And the number is 1. So how about that? Okay. Okay, that wasn't as bad as I thought. All right, cool. Selecting k best would be n log k. Well, this sort and reverse is 2k log k. Would you agree with that? This sort and reverse is 2k log k, which is asymptotically k log k. Now, technically, so here's the long form. The long form is O of n plus 2k log k. Is it not? I think that's the long form. Then I was thinking this reduces to k log k, but maybe that's wrong. Maybe I should just say n plus k log k. I think that's more correct. Good, so let's look at the editorial. I guess it will be n plus k log k on second thought. So I'm not using a heap. What? I'm not really doing any of these solutions, am I? They keep talking about the average time complexity. I'm talking about the worst case time complexity. Yeah, I don't understand the complexity analysis. Let me submit my solution. And then we'll have Neetcode roast me because of my analysis, maybe. Let me ask ChatGPT. What's the worst case time complexity for this algorithm? The dominant term is the sorting step, yeah, but what am I sorting on? I'm not sorting on none. In the worst case where u of n, space, that's space complexity. Right, okay. this is still length in the worst case. So if I had maintained the limit internal to this, if I had maintained the limit internal to this, I think it would be better. In the worst case, I will be doing a k log k sort n times k log k. So let's try that. So we're appending these tuples. I'll keep this block because this works. And then I'll comment it. And let's try to do this at each element of n step. Okay? So I append, and then I sort it, and I reverse it. And I'm going to slice the top k at this point. I think that works, right? It looks slower. All right. Let me ask ChatGPT though. What about this approach where I slice k at each step in? In k log k, is that what I said? In k log k. Yeah, okay, so we're aligned. This approach is less efficient than the original one. When k is significant. When k is significant. Yeah, so if it was unbounded, it would be slower, but it's bounded. It's bounded how? It's bounded so that k is less than or equal to n, which is going to make it n squared log n. So that is still less efficient. It's better only when k is extremely small compared to n, but it's generally worse. Yeah. Okay, so it works, but it's not optimal, right? So we're better off with this other approach. So we're better off with this. K log k or n log n in worst case. So that's it's better between the two, but it's still not very good. Still not very good, right? Yeah, because we're not beating that follow-up. To ensure that n log k is always less than O n log n. The particular case k equals n could be considered and solved separately. I don't know that I buy that. Do you buy that? Because what about the case where k is n minus 1? It's still asymptotically n log n. I guess that's all they're asking for. So it can be asymptotically n log n, but it's strictly less. And that's why they keep going on about the average case then, I guess. Yeah, so that's right. So I could have a special handler, which I didn't implement, which is like, what if, like before I sort, what if if the length of this guy is less than k. Then I'll just call this unsorted. Unsorted elements. So I'll just add that every time, and here I can return a list form of unsorted elements. Okay, so theoretically that saves us the sort here, but it only handles an edge case, so it doesn't make much of a practical difference. It's like, this is like way cleaner, right? This counter thing. What are they doing with this counter thing? If k is the length of nums, return nums. Yeah, sure. It's even better to move that up. And we can say if k is greater than or equal. Okay, that moves us to this faster leg. That's good. And in that case, I don't need this unsorted element structure, because they were serving the same purpose, but one is done earlier. No? Is that a random or is that for real? Okay, it's just a random difference. I guess that's it. Bro, please put it in dark mode. All right, let's try. Dark mode, where are we at? Oh, that's not what I meant to do. Leave classic mode. I have to set a Chrome flag. I have to set my whole browser into dark mode. Nah, miss me with that. They really should add just like a button though. That'd be good. Lucky says if you use max hashmap key equals value, it will return the key with the highest value. I like it. So that's scanning through the hash map multiple times, right? Is the complexity actually better? That's a nice, like, make your code cleaner trick, but in the worst case, I don't think that actually changes the time complexity, right? So Vinci, how long do you stay on a Neetcode problem before moving on to the solution? So I do a time box of 20 minutes, and if I haven't gotten the solution in 20 minutes, I'll look up the solution. But here, yeah, this is kind of different, because like I got the solution, but I could iterate to make it better. In general, I go for like a 20-minute time box on my implementation and then 10 minutes to look up the solution. And I think we've done that here, right? We're at the we're just under the 35-minute mark, and that includes like my intro and whatever. So we're roughly on track. Return max key, k times easy. Yeah, I think that's like equivalent to this, right? It's just like a different syntax of doing this thing. Okay, either way, I think we got it, and I like the problem. I like the problem. Let's encode and decode strings. All right, so let's design an algorithm to encode a list of strings into a string. The encoded string is then sent over the network and is decoded. Okay. Fine. So a naive algorithm on a list of strings would just join them. Right? That would be the naive thing to do. Should I be doing something with bits or base 64? I sure hope not. Gosh, I mean, it feels like a compression problem. It feels like the whole point. Oh, yeah, how do I split them? That's going to be the question. Contains any possible characters out of 256 valid ASCII characters. Okay. Yeah, I need to have like a magic byte here. Or a non-ASCII character. I think the actually efficient way to do this would be to change it into bytes and then have a magic byte delimiter. But like, I don't want to implement that. A hilarious option that's a bad option, since the string is length under 200, I could have a 201 length delimiter and it would guarantee to parse. But it would like, it's like the opposite of compression. It's like making it larger. You are not allowed to solve the problem using any serialization method. Bummer. Here, I think I'm going to just look up the solution. Because I don't have a good approach. So, okay, what if I convert it into... Like if I hash the string, how do I unhash it? If I turn it into a set of characters, I'll know what letters are there, but I won't know the letter order. I'll just do my naive thing here, which is going to be super inefficient, and that is JSON dumps and JSON parse. But I guess that's using an existing serialization method. So that's like what they're telling me not to do. Yeah, I don't know. Oh, so what if I use ORD and I convert every character to a number? It seems to be slowing the thing down, right? Because ORD is going to be expansive. It won't actually be a compression. I don't know. Let's see. Let's see. Non-ASCII delimiter. Yeah, fine. Yeah, some like weird character. Fine. Escaping. Okay, so escaping is expansive, but I guess they're fine with that. Chunked transfer encoding. Ah, the integer here is the trick. So it's like a look back. So we'll split. See, this is weird because you could have, these are ASCII characters, right? /:, are ASCII characters. Am I tripping on that? Yeah, so you could have a substring that is /:. We could use any non-digit delimiter for this approach. I don't think so, dude. I don't think so. ON. Yeah, and it's not better. So the core trick is just to use a non-ASCII delimiter. It's such a trivia problem. It's such a trivia problem. Yeah, so this is fine. The problem is like I couldn't tell you what a non-ASCII character is, but looking at the solution, I know. So non-ASCII characters. Cool. So I'll just grab this one. Maybe in a real interview, they would let you look that up. So I would say non-ASCII. I was talking about using a magic byte. This is basically equivalent. It's a non-ASCII delimiter. So return strs.join non-ASCII, and then return s dot, is it split? It doesn't have join. Oh, that's the JavaScript one, huh? What is it? You just do plus equals, is that? Here's join. Okay, I just got the order wrong. Dyslexia is a pain. I mean, I don't have dyslexia, but if you have dyslexia, it's going to be a pain for LeetCode. Okay, this is fine. It's like a trivia problem, but hey, LeetCode is like that sometimes. This is like probably a useful trivia to know. All right. Hiya, what's up? You ready for the TikTok shutdown? Hey chat, please do follow me on other channels because TikTok is going to be shut down here pretty soon. Product of array except self. Excuse me. Given an integer array of nums, return an array answer so that the I index answer, so I of answer, is equal to the product of all elements of nums except nums I. Okay. Product of any prefix or suffix of nums is guaranteed to fit into a 32-bit integer. Okay. The follow-up is interesting. Can you solve it in O of 1 space complexity? So we want to do this thing in place. So I could get the cumulative product of all nums. That'll be the trick, right? I think that'll be the trick to get an O of 1. Cumulative product equals 1. And then for num in nums cumulative product times equals num. And now nums for I in range length nums, we'll replace it in place, and that way we get to have the lower space complexity. So this would be O of n time complexity in constant space, and then we'll return nums. Is this a medium for real? Okay. Well, let's not count the chicken. Let's not celebrate before I've got it, huh? Division by 0. Oh, there's the trick. Okay. We just say has 0 equals, we're going to assume that it doesn't have a 0. If num is equal to 0, then it's true. Why do I care about that? I don't think I need that flag. Am I thinking through that correctly? So if we have a 0, then the product except self will be 0. And if we don't have a 0, right here, this bit, we don't want that bit. Okay. Wrong. Ooh, bummer. I got my has zeros wrong. If not num. Yeah, I got these backwards. So if not num. Let me say that differently. Say if num is 0. Why? Yeah, why did it double the width there? 6.0? Okay. Okay. Int. I'll just cast it to an int. Okay. Wrong. Boo. So when the nums are 0, 0. Ah, okay. I just totally skipped over a pretty important edge case, right? When they're all zeros. Sabenchi, do you go back to these problems or no? You just do them one time and move on? I do go back to them. I do go back to them. Yes. repetition is key. I'm not going to be doing them multiple times tonight, but I'll have the set of problems that I've done and then a set of unknown problems, and I'll practice on both groups. Highly encourage that. Has non-zero. There's also the case where, like, what if not nums, return nums. Like if it's an empty list. I don't know if that's like going to happen, but we'll go ahead and account for it. So if you don't have a 0 and if you don't have a non-zero, we're guaranteed to have one of them. So this will handle the case when they're both false. So now I'm guaranteed to have one of them. Okay. But I can skip all that stuff if not has non-zero. If not has non-zero, then I should be able to return nums, I think. It'll just be a list of zeros. Boo, wrong again. So I said 0, 4. So I said 404. Okay. This would be a terrible interview, right? Because it's just all about the 0 edge cases, and I basically skipped over those. Right. If you have 2 zeros, let me go for 0 count. So 0 count is 0. For consistency, you might make that a non-zero count, but it doesn't really matter. The 0 count is what matters. Plus equals 1. So if has non-zero, what I should say is if non-zero count if the 0 count is the whole thing, then we can return it. So here, if the current is 0, if the 0 count is greater than 1, if the 0 count is greater than 1, then it's going to be 0. So I can actually pull that out and denest it, which will be nice. So if 0 count is greater than 1, let's see, I don't know if I can denest it. I think so. If the 0 count is greater than 1, then it will always be 0. Okay, so now in this case, there's only 1 0. Maybe you meant double equals. Yep, yeah, I did. This is a tough problem to find the algorithm to solve for the first time. Yeah, it's not that tough. It's just embarrassing. it's not actually a difficult problem. It's just like you can embarrass yourself in the interview. But it really is just thinking about the zeros, which I admittedly was not doing up front. I was thinking about the happy path. So I guess that's like a reminder that we need to be thinking about the edge cases, yeah? But it's still an efficient algorithm, so this will be O of n, worst case time complexity, average case under that, and the space complexity here is constant. So it's really a really efficient algorithm. The brute force is easy, but the optimal is a lot harder. Yeah. So this one is this should be the optimal solution because I'm adding no extra space. You can do it in one for loop. Interesting. I believe you. I just wonder how ugly that for loop would be, huh? I thought it said without division, did it? Oh no, you got me. O of n time without using division. Yeah, I totally fumbled on that. Okay. Man, I totally fumbled on that. So I want to go count my zeros anyway. It's easy with division. Yeah, makes sense. Good call, Raymond. Okay, so if I count my zeros, gosh, I got to scratch this whole thing, huh? So if I count my zeros, if I've got more than 1, I return a list of zeros. If I have 1, then everyone is 0 except the 0. And what if I have no zeros? What if I have no zeros? Now I need a list, right? I need an O of n structure. Nope, I don't see how to do it. I can see how to solve it without division in O of n time complexity. And I can see how to solve it in O of 1 space complexity, but I can't see how to do both of those at the same time. I'm missing that. So I think I solved the follow-up without solving the original. Let's see. Left and right product lists. Yeah, but here won't you have O of n space. Yeah, so that's O of n space. Okay. Interesting. You just need to count to 2, then break. Yeah. I hear you on that. That doesn't solve the main problem that I'm dealing with, though, right? That doesn't solve the concurrent problem of getting the constant space. Bro, I'm cooked for interviews. No, you're not cooked. You just need more volume. You can fail in interviews, and you still get a job if you do n+1, right? So here's what Ludwin. If you think you're cooked for interviews, bite the bullet and bomb. That's my advice to you. Go bomb. And when you bomb, learn something so that if you do a little bit better in each interview, you'll eventually get the job. You don't need, like, almost no one gets their job offer after the first interview. Depends on the company. Some you got to be flawless. Yeah, but if you're playing the market, you don't have to be flawless. I like your advice. Thank you, Raymond. Play the market, not the company. Don't get your heart set on a company. Sounds good, boss. Word. I appreciate it. We love a good listener, man. We love a good listener. So I need to try to understand this better. So in this approach, all right, we got the length of nums. Fine. We prepare an array. Fine. Now, answer I contains the product of all elements to the left. Interesting. Oh yeah, this is like doing division without really doing it. It's like yeah, you're doing division without using the division operator. Cool. That's cool. This is a fun one, dude. This is a fun one. I like it. I like it, to be honest with you. And they didn't need any special, excuse me, I have to keep coughing. And they didn't need any special logic to handle the zeros. I think it's just because they're prepared. They're prepared as zeros. This seems tricky to me though. So we set the left boundary to 1. But what about the case where I2 and I3 are both 0? Then 1 would need to come back and be a 0 again. It's solved on the second pass. That's how it's solved. Because if we go left to right, we're expanding a cumulative product. I need to think about this some more. And if we then go right to left, if there is a 0, it'll knock out that initial one that we almost kind of cheated on, right? I like it. So the core algorithm here is, it's not really quite right to call this 2 pointers, is it? Left and right product lists is the more accurate thing here. Imagine your interview with Facebook, your dream job that pays, and you have to come up with this solution in front of the interviewer who stares at your soul. How in the world can I ever think of this in an interview? You can't, right? You're not going to think of the optimal solution in an interview. You won't. That's why you need to practice beforehand. I've always hated these coding tests. Yeah, they're more like trivia, aren't they? What proportion? I'm not going to mark this as done. I'm going to come back and revisit this one. Some large proportion of Neetcode problems are just trivia. But if it's trivia that pays, so there's 2 tricks to this, right? One is, you don't need to know all the Neetcode problems to get a job. You can actually get a programming role with doing 0 Neetcode problems. All right, so take that pressure off yourself. Don't say like, I need to learn Neetcode to get a job. That's not true. So free yourself up, you've got a job, get a job somewhere, and now view it as a return on investment. You can spend your time learning trivia, and if you succeed in that, it's a great return on investment. I think that's the positive mental model. You have to solve that in 15 minutes for meta because it's 2 coding problems per round. Yep, facts. I think you can go up to 17 though. I think you can go up to 17. Because it's not a 30-minute interview. But I could code this up in under 15 minutes if I remembered the right algorithm. So it's all about basically memorizing this product list approach, left and right product lists. Hey, thanks for being here, chat. Hope you'll follow the page. TikTok is shutting down, so check my bio and follow me on another platform. Thank you so much for being here. I hope you kill 2025. I hope it rocks for you. Hope you crush your year.